Hello and welcome to today's webcast. Can everybody hear me all right? Today's webcast is brought to you by the Center on Knowledge Translation for Disability and Rehabilitation Research, or KTDRR, at the American Institutes for Research, otherwise known as AIR, in coordination with the Campbell Collaboration. The Center on KTDRR is funded by the National Institute on Disability, Independent Living, and Rehabilitation Research, known as NIDLR, in the U.S. Department of Health and Human Services Administration for Community Living. The Campbell Collaboration is an international organization that promotes positive change through the production and use of systematic reviews and other research syntheses for evidence-based policy and practice. KTDRR partners with the Campbell Disability Coordinating Group, or DCG, to help increase the number of Campbell reviews in the disability field. My name is Ariana Hammersmith. I'm from the DC office of AIR, and I will be the moderator today. I'd like to thank my colleagues, Joan Stark and Shoshana Rabinovsky, who are helping with today's logistics. KTDRR and the Campbell Collaboration, are working together to offer a 5-part training course that focuses on high-quality methods for synthesis of evidence, including the procedures and methods for conducting systematic reviews and research syntheses, as well as software, tools, and strategies for analyzing and reporting data. Last month, we kicked off the series with an overview of systematic reviews and research syntheses. Dr. Pigott explained the benefits of evidence from systematic reviews, identified different types of reviews, and discussed the differences between systematic reviews and research syntheses. In this second session, Basic Steps and Procedures for a Campbell Systematic Review, Dr. Pigott describes the steps in conducting review that follows the standards of the Campbell Collaboration, including conducting the literature search, screening of studies, coding the studies, and a look at some of the options for data analysis and reporting. And now I'd like to introduce today's speaker. Dr. Terri Pigott is an Associate Provost for Research and a Professor of Research Methodology at Loyola University Chicago. She is a former Dean of the School of Education. She is currently the Senior Methods Editor at the Campbell Collaboration Editorial Board and the co-editor of the Campbell Collaboration Methods Group. Dr. Pigott received the Frederick Mosteller Award for distinctive contributions to systematic reviewing from the Campbell Collaboration in 2016, and she is an author on 6 completed Campbell reviews. She has served on a number of editorial boards and is the founding chair of the American Educational Research Association Special Interest Group on Systematic Review and Meta-Analysis, and is a member of the Society for Research Synthesis Methodology. And finally, I will now hand things over to Dr. Pigott so we can get things started.
Thank you very much. Good afternoon, everyone. So today we are going to I'm going to provide you with an overview of the stages of a systematic review and meta-analysis, and in particular the overview of the standards for producing a Campbell systematic review using the MECCIR standards. The Campbell Collaboration MECCIR standards, or the methodological expectations of Campbell Collaboration intervention reviews, provides authors and users of Campbell reviews of intervention effects with clear and transparent expectations of review, conduct, and reporting. These are based on the original work of the Cochrane MECCIR project team, which I have the reference there, Higgins et al. In 2016. So this presentation will provide highlights from these standards as for the conduct of a systematic review as I go through the stages today. And there's a link on the slides to directly access Campbell's MECCIR standards. Okay, I'm going to have slides a little bit out of order, so I'm going to start here and talk about systematic reviews itself. So systematic reviews are, just like primary studies, a form of research, and they follow the same basic steps as any research study, but with primary studies as the unit of analysis. So, for example, in a primary study, we all know what the basic steps are, but the same kinds of steps are used in a systematic review, where we start with developing our problem, collecting the data, evaluating that data, and then doing data analysis and interpretation. Systematic reviews, though, use primary studies as the unit of analysis rather than individuals. So our first stage of our systematic review is problem formulation. I'm going to go back a couple slides to this. So in the problem formulation part of my presentation, we're going to talk about 3 questions. What are the kinds of questions that can be addressed in a systematic review? Sort of what is the scope of those systematic review questions? And then how does the review question that you develop shape the inclusion and exclusion criteria for studies included in the review? Okay, so let's start with one example of systematic review question, most common one, I would say, and that is to use systematic reviews to examine the effectiveness of an intervention. So I have an example here from a recently published review, published in the Review of Educational Research. And this study is a systematic review of the effectiveness of academic interventions for elementary and middle school students who have low socioeconomic status. So this kind of review, a review question about the effectiveness of interventions, takes the form of what are the effects of some intervention X on some set of outcomes Y for some population. Or you might see variations on that theme. I'm looking at differences in effects of interventions to different interventions. But in our example that I just gave you, here again, for Dietrichson, the research question is about the effects of academic interventions or the effectiveness of academic interventions for low SES students. Now, we might also have questions, systematic review questions, that are really interested in how 2 different groups compare. So, for example, they might take the form of how does one group X differ from some group Y on some characteristic. So one example of this kind of research question was a systematic review published in Psychological Bulletin looking at gender differences on a range of outcomes such as leadership, math performance, hours worked in the home. So we might also have a systematic review question that looks at the differences between men and women or boys and girls. Another example of that would be the second example here on the slide, which is another recently published systematic review on actually differences between first and second generation immigrant students on academic achievement. So here's another example of using a systematic review question to actually look at 2 different groups. Okay. You might also have a systematic review question that's actually interested in the associations among constructs. So this is a systematic review that looks at the correlation between having been victimized and having been exposed to cyber victimization and your academic outcomes in ages for students in ages 12 to 17. So for example, we might have a systematic review question that might ask about how does some construct X1 relate to some other construct X2 for some set of populations, or some variations on that theme. So the Gardella et al. Systematic review is really trying to estimate the strength, magnitude of the correlation between peer cyber victimization and educational outcomes. So this is another example of a systematic review question. So in summary, there are a number of kinds of different systematic review questions that you might pose. One might be maybe you're interested in the effectiveness of an intervention. So does some program A have larger effects than a control condition or treatment as usual? We might have a question about the comparison between 2 different groups. So do men and women differ on some outcome, group A versus group B? We might have a question about associations between 2 constructs, looking at the strength and direction of the correlation between 2 constructs. We also might have a whole other range of questions that I'm not going to cover here. There are research synthesis and meta-analysis methods for diagnostic and prognostic tests. So in a set of studies, can we look at what test is more accurate at diagnosing some condition, or what test is better at predicting some outcome, or also about prevalence. what is the prevalence of some phenomenon that's estimated across a set of studies. Okay. So systematic review questions can also vary in their scope. We might have very specific narrow questions that are useful for testing the effects of specific treatments, or we might have broad global questions useful for generating new knowledge. So, for example, identifying common elements of effective programs or building better intervention theories to guide program development and evaluation design. I'm going to stop here for a second because I see a question in the chat box that might be relevant. The question is asking if there is a difference in research question between a systematic review and a scoping review. So there really, I would say there really isn't any difference. It sort of, again, depends on, what your aim is. So a scoping review could be used to look at what the literature is, what literature exists for a very narrow question, or it could be used to exist for a very broad question. So I'd say there really isn't any difference between those kinds of reviews in research questions. Okay. So going back to, in terms of the scope of a systematic review question, so for example, an example of a very narrow question in a systematic review might be, in the case of an intervention, we might be interested in just understanding the effectiveness of one particular kind of intervention, such as, for example, in this example, second step, which is an intervention for developing socio-emotional skills in elementary school children. So we're just interested in one particular kind of intervention. But we might also do a systematic review that's much broader in its scope, and where we might ask the question, what are the potential impacts of all interventions that are focused on developing socio-emotional skills in elementary school children? That would be a very broad kind of question. The example we first started with on the effectiveness of academic interventions for children of low socioeconomic status, it would be considered a very broad review. Okay, and the reason why that's important is that the scope of the question will also guide many aspects of the review. Okay, and in particular, the systematic review question guides decisions in the review about what kinds of studies, what are the critical characteristics of studies that will be included in the review. These would be things about what are the participants or patients or clients that we're most interested in. If we're doing an effectiveness, if we're interested in the effectiveness of an intervention, what are the types of interventions that we're going to be interested in? What are the study designs that are appropriate for the systematic review question? What are the outcomes that are appropriate? So problem formulation, again, guides the study inclusion criteria, and we usually use this acronym called PICOS to help us use the systematic review question to identify the kinds of studies that are going to be eligible for our systematic review. The PICOS framework, the acronyms, the P stands for population or participants, or it could also stand for problems or conditions if we're interested in a different kind of review. The I stands for interventions if we are interested in the effectiveness of a particular intervention. The C stands for comparison group. That is applicable if, again, we're interested in the effectiveness of an intervention and we're looking at studies that compare patients or participants that were exposed to an intervention versus those in a control group. The O stands for outcomes. What are the primary or secondary outcomes or acceptable outcome measures that are going to be relevant for our research question? And the S stands for study design. What are the kinds of study designs that are going to be most appropriate for our question? Or in some cases, you might also see the S stand for settings. What are the settings of the studies that we're going to be interested in? So for example, if we think again back to our first example on academic interventions for low-income students, the settings were schools. Okay. So again, our first example, the Dietrichson example, the PICOS for that study that systematic review. The P is low-income students in elementary and middle school. The I are interventions explicitly aimed to improve educational achievement that could be implemented by schools. The C was a typical non-treatment control condition. The O were standardized achievement or academic tests, and the S were randomized controlled trials or controlled quasi-experimental studies. So this PICOS comes directly from the research question in that systematic review. So in summary for problem formulation, as is true in any primary research study, the systematic review research question guides all other decisions made about the methods in the study. And I've given you a range of kinds of systematic review questions that would be appropriate, things about effectiveness of interventions or differences among groups or associations among constructs. Systematic review questions can vary in their scope. They could be very narrow questions about a particular intervention and the effectiveness of that intervention, or they could be very broad questions designed to understand the literature on a topic. These broad questions are, if you're familiar with the Institute of Education Sciences Goal 1, the goal framework for their funding opportunities, broader questions tend to be eligible for the IES Goal 1 funding. Obviously, systematic reviews are most productive when there's a large body of literature, although both the Campbell Collaboration and the Cochrane Collaboration have published reviews that have no studies in them. Sometimes you do a review and you find out that none of the studies that have been conducted are eligible given your criteria. But again, the research question leads to those PICOS, the inclusion criteria for studies eligible for the systematic review. Okay, so let's move on to our second stage, which is data collection. So in a systematic review, data collection means we're searching the literature to collect all the primary studies that we can that examine the research question and that meet the inclusion criteria. So again, the unit for our systematic review is primary studies. And so what we want to do, as we want to do in a primary study, is to get some sample of, in this case, studies that will generalize to some hypothetical population of studies on a given research question. We want to be able to make the case that the studies that are in our systematic review are representative in some way of our of all the population of studies that have been conducted. Okay, so we want to use a search strategy and also document that search strategy so we can support the argument that we have found a representative sample of studies. The next couple of slides are based on the source that is the bottom of the slide here, Kugli et al., 2017. This is the Campbell Guide for Information Retrieval. And so I'll be relying on that source for the next few slides. Okay, so some things to consider when you're developing your search strategy to identify a set of studies that are potentially eligible for your systematic review. You need both sensitive, which are very broad, and specific, which are very focused searches. So if you've ever used Google Scholar, you'll note that if you use Google Scholar, for example, as a search strategy, those are very sensitive and very broad searches. You get a lot of hits, but they're not very specific. Databases like ERIC or PsycInfo are much more specific. You would need both kinds of searches to be able to identify a set of studies for your review. You should think about the use of keyword searches of multiple databases, and it's important to know the knowledge of those, have some knowledge of those keywords used in each of those databases. Every database is usually tied to a discipline, and each of those disciplines use different kinds of keywords to represent the same phenomenon. It's also important to search multiple sources of gray literature, of unpublished literature, such as websites, dissertations, special registers of studies, and so forth. The reason why that is important is because, as we know, it's been well documented in the social science literature that publication bias exists. So that published literature tends to have larger effect sizes. And so we do need to make sure that we have a representation of the gray literature as well, so that we have an unbiased estimate of whatever that effect is that we're interested in. And also people also use hand searching of selected journals to find relevant studies. In thinking about the databases to search, it's also important to remember, and this is true in many fields, but particularly in disability research, that many researchers across many disciplines, multidisciplines, are interested in the issues that arise in disability research. So you'll need to think through that there are researchers in education, in medicine, in psychology, and sociology that are interested in these questions, so that you will need to search multiple databases in order to make that case that you have found all the studies on a given topic. Appendix A in Campbell's Information Retrieval Guide provides a list of potential databases to consider. The search strategy in general tends to have sort of three different sets of terms. So if you're interested in an intervention, if your research question for your systematic review is about the effectiveness of an intervention, the three sets of terms tends to be something like the condition of interest or the population that you're interested in, the interventions or components of the interventions that are important, and the outcomes. And again, each database may use different terms for the same phenomenon, so it's really important to understand the concepts in each discipline. And the formulation of those search terms will include controlled vocabulary, which is the vocabulary that's specific to each of the databases. The use of keywords, the use of Boolean operators, and the use of limiters. Again, the Campbell's Information Retrieval Guide gives you some examples of this. My next slide, which will be hard for you to see, but is an example of one piece of a search strategy that we used in a review that is available on the Campbell Collaboration website on teen dating violence prevention programs for high school students. And you can see here in just a little piece of that search string that it uses prevention or intervention as one search term, then the actual kind of intervention that we're looking at, sexual violence, sexual coercion, peer support, and then the type of study design. So this is just one example of that search strategy. If you look up, and the reference for this review is in at the end of the slide deck, you can look up the completed review to see the examples of the search strategy. Okay. So, but my go-to is I am not a specialist in search strategy, and I think one of the best advice I can give you about searching literature is to find a librarian or a search strategist, search expert who can help you navigate the multiple databases that you'll need to use to do a systematic review in disability research. Okay. Another issue to consider is that it's very important to document your process from start to finish. One of the MECCIR standards is to be able to provide documentation of your search strategy so that it can be replicated. And it's important to document all the information sources you searched, the dates covered in that search, and the date of the search, and your full search strategy, including the limits and keywords for each of the databases you search and for replication of that search. It's also important to remember that searching is an iterative process. While you're trying to define your key concepts and discovering appropriate search terms, you may go back and forth. And I see there is a question here. As you begin your search, you may come across better search terms. Can you revise your search terms? Yes. In fact, you will always revise your search terms. That is just what happens in the search process. Again, it is an iterative process. It's very difficult to know ahead of time, what search terms are going to be most appropriate in each of the databases. Another really important thing to think about is to use some kind of software to manage the whole search process. So there are links here to EndNote and RefWorks. These are two reference manager software programs that are that you have to pay for, but for some of you who might be attached to an educational institution, you may have access to those particular reference managers. There's also a link there to Zotero, which is a free reference database manager, which I have some familiarity with. So how these reference managers work, so I'm going to give you, there's a screenshot in the next one. So for example, here is the, if I happen to be searching and I see a article that I think is important, you can see here I've circled in the top right-hand corner, there's a little picture, it looks like a book, I think. If I click on that when I have my Zotero open, that reference will just be uploaded right into my reference manager. And I don't have to do anything else, and it'll go into a library that I've set up. And it'll also, it can also download the PDF or a link to the PDF that I can go back to. Another way that Zotero works is if while you're in your search, if you save a bunch of items in your, after you've, say, searched Eric, you can put all the results of your search into a folder, and then you can directly download that, all the items in that folder, usually using some kind of link in your browser that directly exports them into, as you can see, a bunch of different citation managers, including EndNote, ProCite, Reference Manager, and Zotero. So, so the use of these reference managers are really important and help you organize the number of studies that are identified in your searches. Okay. So to summarize, I can't stress the importance enough, the importance of the information retrieval search process. This is this is the stage in which you are trying to gather all the studies or some representative sample studies on your topic. It is not a one-shot deal. It is definitely it can require several iterations or searches, so you need to make sure you have a way of documenting those. It requires some expertise in planning and implementation of the searches, so that's what is so important to have a library or search specialist. It's also important to use some kind of management software to store, manage, and organize those results, and then also to document that search so that others can replicate it. Okay, so let's go on to our third stage, which is data evaluation. So once we have identified all the studies that might be important, and then the next steps are to identify the studies that meet the inclusion criteria and then to code the information from those included studies to use in the systematic review and meta-analysis. So, so Joan has asked, is there a minimum number of studies in order to have reliable data? No. This is the part of systematic reviews that I would say is an art. But I think what you're trying to do is what I always tell people is that we're trying to make an argument that you've done your due diligence in trying to find all the studies on a given topic. And that argument is going to be based on sort of a range of, the argument is stronger if you can say, I have searched a range of databases, I have used this range of search terms, and these are the number of studies I identified. So I think that you think about how do I build that argument that I have done a good job of trying to identify all of the studies that might be relevant. Okay. So again, data evaluation is there are two stages to that. One is screening to identify the studies that meet the inclusion criteria, and the next is to code that information so that we can use that in the systematic review and meta-analysis. Okay. So we're going to start with screening. So screening of relevant studies usually takes place in sort of two waves. So the first initial screening is usually based on just reading titles and abstracts. And we use this sort of screening, this initial screening, to exclude obviously irrelevant articles such as opinion pieces or non-empirical studies. So that even though titles and abstracts are sometimes unreliable and bear no relationship to the content of the study, the first screening does, really does tend to exclude those studies that really don't include any research data. The best practice, which has been demonstrated in empirical studies, is to really use double coding by two trained raters working independently. Because again, this is the stage at which we are trying to be accurate at getting the eligible studies. So you want to, again, make the case that you've done everything you can to include all the studies that are eligible for your systematic review. And then there are also machine learning strategies that we can use for screening that can help the screening process. So I'm going to show you a screenshot of one of those databases, which is called Abstractor. Abstractor was developed by colleagues at the Center for Evidence Synthesis in Health at Brown University. And this is software freely available that is designed to screen for systematic reviews. What it does is you upload your list of studies, the titles and abstracts for your set of studies into Abstractor, and then you start to code those studies. And as you code the studies, and you start to screen those studies. And as you screen the studies, and that screening is just in or out, is the study eligible or not? The machine learning algorithm in the background resorts your studies by the probability that your study will be eligible for the systematic review. So it begins to learn as you're coding which studies are most likely to be eligible for your review. This can really help in the screening process. It also helps you organize multiple screeners. There are ways to set up an Abstractor project that will help you use multiple screeners to look at the same data and produces reports on the agreement of between those two screeners. So this is a really useful and free tool that can help with the abstracting, with the screening process. And the reason why you need this is in this next slide. So as you can see, our first example, the Dietrich et al. Example, initially identified 11,000 or almost 12,000 studies in the search. So that is an enormous number of studies that have to be looked at by two different people to decide if they're in or out. And you can see sort of I've given you a range of initial numbers of studies that are typically identified in a systematic review. And so a tool such as Abstractor is really important. And I just want to point you back to the chat. Jonas told us that on April 17th, there will be another session in the series that actually will talk about these kinds of this kind of software that can really help you manage your systematic review. Okay. While we're on this slide, I want you to note here the number after the first screening. You can see that, for example, the Dietrichson study screened 12,000 studies to get to 1,000 that passed that initial set. So there were still quite a few studies that had to be looked at in the systematic review. Okay, so after you initially screen just the titles and the abstracts, will you move on to the second stage of screening, which is screening full text of potentially eligible studies? And this is where your list of inclusion or exclusion criteria that was based on the PICOs comes in. So you're going to now use the full text of the potentially eligible studies to look at those elements of PICOs to make sure that each of the studies, and using the full text of the studies to see how they conform to your PICOs. Best practice is, I say blind here, but what I really mean is independent double coding from two different coders. And it's really important, again, the recruitment and training of the coders as you're trying to keep the process of identifying eligible studies as reliable as possible. Okay, so this next slide shows you a PRISMA flowchart, which is the way that we document the search process of a systematic review. So the top box shows you the number of studies that were identified in the search. And this PRISMA, this particular PRISMA flowchart is related to, is the flowchart for the teen dating violence prevention systematic review that I talked about earlier. So you can see that we started with 1,600, well, you can't see, but we started with 1,600 potentially relevant studies. 1,500 of those were excluded in that abstract and title screening because they weren't empirical studies. 90 were left. 90 were left for a full text evaluation. After that, 22 more were excluded because they didn't meet the PICOs. 68 then were identified and used to try to, and then used in the next phase, which I'm about to talk about, in the coding phase of the review. Okay. So once you have that complete set of eligible studies, your next step is to code aspects of the study content and also to get the effect sizes. So what you would normally do is develop a coding manual that includes codes for recording things like the setting of the study, the author's publication date type, the methods used in the study, and the quality of the methods, which I will talk about in a moment. If you're interested in an intervention, you would be coding things like components of the intervention and what was happening in the comparison or control group, coding things about the participants or the sample, the outcomes, and then the effect sizes. So here's just a little example from the coding manual of the teen dating violence review. And we can see here this looks at, for example, sample and program characteristics, asking asking the coder to say what is the general SES of the students in the sample. There's some questions about what was the dependent measure, what was the outcome measure, was it teen dating violence knowledge, was it attitude, how was the outcome measure reported? So there's a question here about managing the coding, and I'll get to that in just a second. Okay. So the reason why we code is to develop and provide descriptive details of the studies included in the systematic review. So when we're reporting out the systematic review, we can understand sort of the landscape of the evidence base, and then also helps us to identify gaps or issues in the evidence base. And then also to record information about study effect sizes so that we can later examine and explain the differences we might find in effect sizes across studies. Okay. An important thing to think about is the coding of study quality. There are a myriad of ways to actually code study methods that are used, the study quality, the quality of the study methods used. So, for example, there's the Cochrane risk of bias framework, the grade system. There are many, many method quality checklists, direct coding of methodological characteristics. So, for example, you might code whether or not, if you're looking at if you're interested in effective intervention and you're interested in experimental studies, you might code whether or not there is evidence that the treatment group and the control group were balanced and looked similar to each other at the beginning of the study. And we use these sort of ratings and coding of study quality in a meta-analysis to examine if the results across studies differ by study quality. So I'm just going to give you here an example of the Cochrane risk of bias framework, which is most relevant to randomized controlled trials. The items here are for each study. You rate the quality of these items for each study, and you can see that these questions here are really focused on the quality of the randomization and the quality of the study itself. So, for example, attrition. Was there differential attrition between the control and treatment group and so forth? So this is one example of a way to code study quality for each study. There are also coding strategies for non-randomized studies. The Newcastle-Ottawa scale really focuses on case control and cohort studies, focusing on the quality assessment of those kinds of studies. And I've given you a link here for those kinds of studies. Lots of different methods are used to code study quality, and it really is up to you to think about how you might want to do that depending on the kinds of studies that are eligible for your systematic review. Okay, so other issues to consider. Reviewers definitely develop these coding manuals for reviews, and I have to go on record here of saying that coding is the most time-intensive portion of a systematic review. And best practice is to use software to conduct and organize that coding. Some of my colleagues are very good at database software and are able to develop Access or FileMaker coding strategies that are very elegant. Many people use Excel or Google Sheets if you're sharing across, to actually code these kinds of things in each study. So this is a another important thing to consider when you're planning a systematic review. How are you going to manage the coding part? What kind of software are you going to use? Also in this stage, it's important to attend to the training of coders, use double coding when you can, and to record sort of the reliability of your coding decisions. And continually check on that as you're coding through studies. So common challenges in this stage. It's impossible to underestimate the time needed to prepare and code studies. This is just by far the most important and time-intensive part. Again, just like the search strategy, coding protocol is not, don't assume that the coding protocol is not an iterative process. Developing a coding protocol is definitely an iterative process. There is there's always something that you've missed once you start reading these studies. Important to attend to coding drift. All through the process, check that all your coders are interpreting the items in the same way. And to just organize and supervise that process by making sure that your coders continue to be motivated to do it and using appropriate software. So we have a question in the chat box. Is there a way to register your systematic analysis so that someone else isn't doing the same thing? There are a couple registries for protocols. Obviously, the Campbell Collaboration helps you to register and review your protocol. So there's one place to look to make sure that someone else is not also doing the same kind of work. It's escaping me right now. Let me get back to you, Lynn, about the other registries. There's a systematic review is an open access journal that also registers protocols, and that's a place to also look. Thank you, Joan. Prospero is another registry of systematic reviews where you can look to see if other people have registered a systematic review. Okay, and I touched on this in my first webinar. Okay. Okay, so now we have talked about problem formulation, how we search for studies, how we screen and code studies. Now we're going to talk about data analysis and interpretation, and I'm going to try to get through these fast. I don't give a lot of detail here, but I'll just give you an outline. So once you have coded all your eligible studies, the analysis consists of normally two stages. One is just to describe the studies you're included, usually in some narrative and table form. So good systematic reviews will, give your reader some sense of what the landscape of the literature looks like by saying, I found this many studies, these are the kinds of people in them, and so forth. And then when possible, you want to do a meta-analysis, especially if you're interested in, in estimating, say, the treatment effect of some intervention or the magnitude of the correlation between two constructs. And as in any statistical analysis, that analysis includes examining what the average effect size is and its confidence interval, and then also exploring why, exploring how variable, how heterogeneous those results are across studies. And then if it's not possible to do a meta-analysis because you only have one or two effect sizes, you would think about doing a narrative discussion of study results. Okay, so the meta-analysis is focused on effect sizes. Effect sizes is our unit of analysis in a meta-analysis. So for every study, we express the results of each study using a quantitative index of effect size. And we think about effect sizes as a measure of the strength or magnitude of a relationship of interest. So that might be the difference between the treatment and control group. So that treatment effect, it might be a correlation. Effect sizes have the advantage of being comparable. They estimate the same thing across all studies and can be summarized then in a meta-analysis. We use effect sizes because not every study uses the same measure of a particular phenomenon or outcome. So for example, math ability can be measured by a myriad of number of different measures, and so we use an effect size so that we can say something about math ability across all these studies, even if everyone's not using the same measure. Please note that session 5 of this series will be talking more specifically about effect size and meta-analysis. Okay. So here's just an example of what's called a forest plot. Each of the rows of this chart is a different study, and you can see that what is in the middle there are representation of the effect size. This is the difference between treatment and control groups on their knowledge of teen dating violence after the treatment group has been exposed to an intervention. The dotted line in the middle is the zero line, no difference between treatment and control. And then you can see that each study has an estimate of the effect size, which is the square in the middle, and then the confidence interval around it, which are the whiskers. On the very bottom shows you the average effect across all the studies. So this is just an example to show you how we might represent a meta-analysis. It gives you a sense of what the average effect is across the studies and also how variable they are. Okay. As in any statistical analysis, I just wanted to put a plug in for this, the mean and its associated standard error may not be the best representation for distribution of error of data because in education and disability research, we expect that study results will not be exactly the same across every study. So an important part of any meta-analysis is also examining the amount of heterogeneity across the studies, across the effect sizes in the studies. In meta-analysis, with a sufficient number of studies, we can explore potential correlates of heterogeneity. So we can use, if we only have one categorical predictor, so say we want to compare randomized controlled trials to quasi-experiments, we can use a simple one-way ANOVA model. If we have multiple predictors, we can use meta-regression to examine if there are predictors of the variation in effect size across studies. And a common predictor of heterogeneity is the study quality, as we talked about earlier. We typically use study quality as an important predictor for examining the variation across studies. Okay, so what I have here is an example of sort of an analysis of why studies might vary based on based on studies that used random assignment versus non-random assignment. This is, again, the teen dating violence example. If we just look at the first row, these are the effect sizes for teen dating violence knowledge, studies that used random assignment and studies that did not. And we can see that the studies that used random assignment have a larger effect size, 0.36, than studies that did not use random assignment. So this is an example of the exploration of heterogeneity using study quality. And again, you can find this source in the Campbell Library, free access, and you can see an example of this. Okay. Some computational challenges that might exist when you are using meta-analysis, when you're trying to compute effect sizes and so forth. Every researcher I know that's used systematic review runs into the problem of missing data in primary studies for computing effect sizes, particularly in older studies. Many of the older studies don't give you the information you need to calculate an effect size, so that you will run into that problem. It's also a problem sometimes getting appropriate effect sizes for complex designs in primary studies. There's much research going on about that. How do we get an effect size for a clustered randomized trial? How do we get an effect size from a study that only gives you the results of their regression models? You might run into issues around combining effect sizes from different metrics. What if some studies give you a correlation and other studies give you means and standard deviations? Another common problem is that there are multiple effect sizes presented within studies. I have never seen a primary study that only gave you one outcome. There are usually multiple outcomes. This leads to a problem with dependent effect sizes. This is a common challenge as well in meta-analysis. So you might have to consult with a meta-analysis specialist when you run into some of these issues. So in summary, data analysis interpretation. I always tell people this might be the stage that people feel most anxious about, but is certainly not the most time-intensive part of the systematic review. Most of the time, again, is in coding. But exploration, if you're going to use meta-analysis, the exploration of heterogeneity is really of greatest importance because we expect variation across effects in studies. So you need to carefully plan for moderator analyses, for the exploration of heterogeneity, both in the coding stage and in the analysis, so that when you're coding for studies, you should also be thinking about what are the reasons why studies may vary in their effects, and you want to make sure you code each of your studies for those issues. It's also important to be very careful when we interpret these kinds of analyses because we're talking about relationships among characteristics of studies rather than relationships among people. Okay. And that because there's so much development of statistical methods in this area, you want to make sure you consult with someone who has done a meta-analysis before. Okay. Finally, we might need to use narrative synthesis when there are few or no studies identified for the review, or if, in fact, the review question we're interested in is really interested in a more conceptual understanding of the literature rather than aggregation or estimating the effect size. There are lots of methods for narrative and qualitative synthesis that also focus on transparency and replicability. And Campbell is beginning to develop standards for these types of reviews. Okay, so we've come to the end of my, my talk. Here are some of the references that I've gone through, and I just want to thank you for your time.
Thank you, Dr. Pigott. That was a wonderful presentation. Let's see if the audience has some questions for you. Okay,
I'm going to talk a little bit about developing a protocol or plan. I would start at the Campbell Collaboration website, but a protocol for systematic review is basically just laying out everything that everything you anticipate you're going to do. And so going through the MECCIR standards will help you develop a protocol. But you want to, in a protocol, document, talk about your research question, give a rationale for why that research question is important, connect with prior reviews that might have been done on that topic, and then go into the methods you're going to use. And so basically a protocol will say, we're going to search these kinds of databases. We're going to possibly use these kinds of search terms, and then it goes into details of the meta-analysis. The Campbell Collaboration is a really good resource for looking at examples of protocols, as well as the Journal Systematic Review.
Wonderful. Any other questions for Dr. Pigott from the audience? So I'm actually curious how, since our center is focused on knowledge translation, how authors of systematic reviews can make reviews more accessible to a wider audience, and if you can speak to experience writing plain language or lay summaries.
Yeah, I don't normally do that. You know, my advisor, Larry Hedges, often says that if you want to understand how people understand systematic reviews, you probably don't want to ask the statistician. But I would say that it is really important to me that people use systematic reviews. And when you read a systematic review, part of the problem with the knowledge translation part is because they are trying to give you all the results you need, all the information you need to replicate that review. But I would say that it's really important when you're finished with a systematic review to really think about, what are the key messages we want to give to a policymaker? How do we want to express both the average effect that we found and our uncertainty around it? And so it's just, again, the Campbell Collaboration has a number of examples of plain language summaries that do that, I think, really well.
I see. Thank you very much. It looks like we've got one more question in the chat box if you have time.
Yeah, sure. In a broad scope, so the question is, in a broad scoping review, a search will bring an enormous number of articles. Is it ever appropriate to use title and abstract only in the initial search? So I think if you're asking about screening, yes, you will always have an enormous number of articles identified, usually in that initial search. So your first level of screening will be just looking at title and abstract, and that tends to help you get way down it helps you eliminate all of those articles that probably don't have any empirical research in it. I hope that was the answer to your question.
Okay, great. Firstly, I want to thank Dr. Pigott for taking the time to prepare and to give us this description of the steps in preparing a systematic review that follow the standards set by the Campbell Collaboration. I'd like to thank everybody for participating this afternoon, and we hope you'll take a few minutes to give us some feedback about the webcast by filling out a brief evaluation. The link is listed in the slides, and it has been posted in the chat box. We'll also be sending an email with the evaluation link to everyone who registered. And finally, I want to thank all the AIR staff and representatives from the Campbell Collaboration who helped with planning and logistics. And of course, we want to thank NIDLR for their support to offer these webcasts and other events. Lastly, we want to invite you to attend the third webcast in this series, Management and Analysis Tools for Reviews, that will take place in 1 month on Wednesday, April 17th at the same time. And we'll have several presenters talking about a variety of software tools to help manage a review. As a courtesy, everyone who registered for a previous session will be registered for the other sessions in the series. We invite everyone to visit our recently refreshed and updated website at ktdrr.org, and I can post that link in the chat box in a moment. Thanks again, and have a nice afternoon.